Okay, I'm going to show you module 1, lesson 2. I just quickly wanted to show you what the lesson is teaching us. It actually is a whole lot of review on what we did in lesson 1. They give you a number and they want you to put it in the place value chart. Now, the place value chart looks confusing when you first look at it, but really all we're saying is any number just to the left of the decimal point, here's the decimal point, is always in the ones place. And then to the left of that is the tens place, to the left of that is the hundreds place. If we had things in the decimal points, that just means it's less than one whole, 1/10, 1/100th, or 1,000th. The first two examples I'm going to give you don't have any decimal points yet, but we're going to look at the first problem, which is 367 times 10. So like we did yesterday, we put 3 in the hundreds place, 6 in the tens place, 7 in the tenths place, and then 10 has 1 0. So I'm going over one time, right? So my 3 ends up here, my 6 ends up here. See, I just went one box over, and my 7 ends up here, and then I can never leave a blank, so my blank ends up being 0. So 367 times 10 ends up being 3,670. Now, without the place value chart being involved at all, you probably already figured this out. All I'm doing is taking 367, and since I'm multiplying it by 10, I'm just adding a 0. Because when I put that 0 at the end, what it actually did was bump the whole number up one spot in the place value chart. And that's how a place value chart works. Every time you go up 1, you're multiplying by 10, right? 1 times 10 is 10. So every time you shift up 1 in the place value chart, you're getting 10 times bigger. Every time you shift down in a place value chart, you're getting 10 times smaller. So if I went from the ones place to the tenths place, I'm actually dividing by 10. I'm getting 10 times smaller. So each shift in the decimal place is just either 10 times bigger or 10 times smaller. So if we looked at 367 and we divided it by 10, instead of shifting up, because shifting up always means when we shift this way, that's multiplying. Up is multiplying, right? When we shift that way, this number's getting smaller, down means divide. Let me shift this so you can see. Down means divide. So when I take 367 and I divide it by 10, I'm shifting everybody over 1. So 7 ends up here, 6 ends up here, and 3 ends up here. My decimal point never moved. It's always staying in the same place. So my answer went from being 367 to 36.7. What I need you to see is that there's another way to look at this. If my number is 367 and I'm dividing it by 10, so that means I need this whole number to get 10 times smaller, right? If I need this whole number to get 10 times smaller, and I know that right now there's a decimal point right here, then I'm actually moving the decimal point to right here to get 10 times smaller. On the other hand, if I was getting 10 times bigger, I had 367 times 10, I'm getting 10 times bigger, I knew that the decimal point was right here, because the decimal point exists in every number at the very end, but I need it to be 10 times bigger, so I'm technically shifting the decimal point over 1 and putting it there. That's how my answer became 3670. So there's two ways to look at this type of math. Either you're imagining all the numbers shifting up one place value, or you're imagining all the decimal points shifting down one place value. Okay? So when you try it in your problem set, you're going to do much the same thing, only you may not need to use the place value chart. If you do need to use the place value chart, use the one that's in your dry erase and practice shifting the numbers. But if you understand that when things are 10 times bigger, you're putting 1 0, or if something was 100 times bigger, you would put 2 zeros, or something was 100 times smaller, you're just shifting it down 2 spots. But we're getting to the point where we can start doing it without needing to draw it in a place value chart. We understand that we can really do it just by visualizing what's happening to the place value. Again, the important thing to know is every time you shift up, you're 10 times bigger. Every time you shift down, you're 10 times smaller. So if you shift down twice, 10 times 10 is 100. So if I shift it down 2 times, that's 100 times smaller. When I divide by something by 100, that's 100 times smaller.